Hello, everybody, and welcome back to the STEAM train. I hope you guys are all doing well. It is Thursday afternoon, and that means it is time for our older lesson of the STEAM train, focused for kids in 3rd to 5th grade. But kids of all ages can join in and follow along. I hope you guys are doing well. I am Mr. Dorian with New Minds. And don't forget, if you've missed any of these lessons, feel free to check any of mine or my coworkers out at newminds.tv to see lots of awesome experiments, lessons, things to do while you're stuck at home. I hope you guys enjoy. We're going to go ahead and get started today. I have something super cool I want to show you. This is going to be my helper today. You might recognize him. He's an older helper. He's going to be really good for today's experiment. What we're showing today is energy, but not just any sort of energy that's still, and energy that moves. There's a couple cool things we're going to do with this, but the first thing we need to learn is what is energy. Energy is anything that can cause a reaction or motion. Not all energy is motion. Something can be sitting still and have a lot of energy. Something can be moving very fast and have a lot of energy. But it's something that can cause a reaction or motion. So even chemicals can have energy in them. We're going to learn about two types of energy today: potential energy and kinetic energy. Potential energy is a little more confusing, so we're going to do kinetic energy first. When something is moving, a force has caused that. So if he is moving across the screen from one end to the other, he's going to have energy. Whether it's me putting energy to move him with force, or if something else launched him across the screen, he had energy put into him by something. Something gave him the energy. When something is moving, that's called kinetic energy. So if he is falling, that's kinetic. If he's sliding, that's kinetic. If he's going up, that's kinetic. All of that is kinetic energy. The important thing to know about energy is that energy never goes away. It just changes places or forms or shapes. For example, if he stops moving, that doesn't mean his energy went away. That just means it transferred into something else. His energy may have went to the friction with the ground and may have caused heat. Maybe his energy has changed into potential energy. Potential energy is the complete opposite of kinetic, but they do work together. Potential energy is when something isn't moving, but it's ready and it's building up a lot of energy to move. One way that this looks like is holding something really high in the air. Everybody knows the second I let him go, he's going to start falling. He's going to start changing his potential energy into kinetic energy. So he's going to lose potential energy as he gets closer to the ground, and his speed's going to go up and up and up until he hits the ground. It goes back to potential. Or, if I'm getting ready to push him, and my hand is wound up, all my muscles are tightened, there's potential energy in them, and then I smack him, my energy is going to transfer into his potential, turn it into kinetic. Different things are going to cause different amounts of energy. Mass is one really big contributor. If something has a lot of mass, or weight is almost the same thing, it's a little different, but it'll help us for today. If something is really heavy or massive, it will fall with more energy. So potential energy is when things are stored up and waiting, and kinetic is when you let it go to its maximum speed. One really easy way to see potential energy is this rubber band. If I just set it here and I just set it down, it's not going to do anything, it's not going to move. To put some potential energy into it, I'm going to stretch it. Now that I stretch it out, it's fighting against me and it's pulling because it's full of energy. It's full of potential energy. When I let it go, what's going to happen? It's going to move, right? I'm going to let go and it's going to shoot off. That's because this potential energy, now that it's released, has to go somewhere. It's not just going to stop stretching and fall straight to the ground where I left it. The energy is going to continue going, and it's going to transfer into kinetic energy. It's going to continue to move. So if I want to shoot this rubber band, I fill it with potential energy. Maybe if I shoot it up, it's going to fill with kinetic. go all the way up, and stop in the air for just a little tiny frame or second. And then it's going to come back down, full of potential. It's going to have kinetic again, and then it's going to hit the ground. So when I shoot it, oh, I hit my own finger. Ow. Let's try again. It's going to turn all the potential into kinetic. But you notice I said that things stop when they get in the air. It's not going to stop in a way that you'd be able to see, but it's actually going to stop for just a very little, because the speed has to change to 0 before it can go in the other direction. So let's say its speed is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It's going to be 0 for just a little second. But gravity's going to immediately start pulling them back down. It's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And start building speed again. The more speed you have, the less potential. The more still you are, the less kinetic. And they're going to act like a balance. So when one goes up, the other goes down. They work together to make a lot of different cool reactions. One of the best ways to see it is with a pendulum. Now, you might not have seen a pendulum before, but you've definitely seen a swing. This acts just like an example of a swing. So when I pull it off to one side and hold it up, which energy is it filled with at the top? It's filled with potential because it's not moving, but it's getting ready to move. What's going to happen is as it goes, it's going to get the maximum speed in the middle, because that's when it's done moving down, moving down, moving down. And then it's going to start going back up and fighting gravity. So while it's working with gravity, it's going to turn potential into kinetic. And it has the most kinetic when it's passing the middle. And then it's going to start turning that kinetic back into potential as it goes back up and has gravity pull on it. In a perfect world, a pendulum would go forever. The energy would keep transferring perfectly, but we have some things like drag, which is friction in the air that's going to cause heat, and different things like friction on this axle. They're going to cause the energy to go away a little bit, but it still will go for a little bit. So let's see if we can test it out. So I put it halfway to give it maximum potential, and it's going to change. Potential, kinetic, potential, kinetic, potential, kinetic, potential, kinetic. The cool thing is that this energy will never get bigger. So a test is, if I put it right here, and I measure out the same thing on the different side, I can put my hand here and I know it won't touch it. Because the energy is going to continue to shrink because it's going into friction. But even if it was perfect, it would stop at the same distance. If I put it about halfway across, it's going to go halfway across. If I put it all the way over here, it's going to go all the way over here. And if I put it halfway up, it's going to go almost halfway up. And you can see the energy changing in real time, and you can see how it always equals out. And this is the same thing that's if you're swinging on a swing. You go all the way up, you're going to expect to go knocked over my pendulum. You're going to expect it to go all the way through on the other side, and then it's going to come back. That's why you notice you're fastest when you're closest to the ground on a swing, because that's where you have the most kinetic energy from all the potential of you swinging up high. Another cool thing that happens is sometimes things bounce when they hit the ground. All their energy changes and goes back into kinetic again. This uses the same idea like a rubber band, but it does it in a different way. A rubber band wants to keep its shape. It wants to stay rubber band shaped. It wants to stay like a circle. It doesn't want to suddenly be stretched out and stay like that. So it wants to go back into a shape. The same thing happens when we have something like a bouncy ball. When something bounces, it's going to go down, and all the force is actually going to go into the ball. It's going to shake, and it's actually going to compress a little bit. If you've ever watched a slow motion video of a bouncy ball, it's super cool because you see it almost turn into a pancake, then it goes back into a ball and it shoots itself up. So my potential energy is going to be way up here. It's going to turn into kinetic. As it hits the ground, it's going to turn into potential like a rubber band, and then it's going to shoot back up. That's why you notice all things that are bouncy balls, they want to keep their shape. You're never going to have a soft bouncy ball, and they're going to be able to stretch a little bit. If it was perfectly rigid, like this wooden ball I have that's the same size, it's just going to make a thud and not go anywhere. This one's a little better because it's plastic. It has a little bit of bend to it. It wants to keep its shape, and it does bounce a little higher. But this bouncy ball is made out of rubber. It wants to keep its shape, and it's really elastic. and it bounces really far. It almost went off my table. So these three different things, they're all balls of the same size. They're all about the same mass, but they have different amounts of elasticity, or how much they stretch. So that's going to let them keep energy much better. If it doesn't keep the energy in the ball, it has to go somewhere. So it's either going to go get absorbed by my table, which is actually meant for you not to bounce. So it's pretty impressive that this ball still bounces. Or it's going to get absorbed into the ground. Maybe it might make a crater in the sand or the dirt. That's why you notice hard ground is better for bouncing things, and soft ground like carpet or sand isn't really good for bouncing. The cool thing is that you can use this to your advantage. Just like a swing, you can use potential and kinetic energy. You can use this when you jump. If you bend in your legs and you get them ready, you're building elastic energy. That's potential in your legs. You jump and you start to go really fast. At the top of your jump, you stop for a second. And then you start coming back down. You notice you can jump up on something and land really softly if you land there at the top of your jump. So if you jump as high as you can and you land softly, that's because you don't have any speed going down. But if you jump up really high and then come down really high, it's going to hurt when you hit the ground. You can actually use this to play this game right here. This is a super cool game called a kendama. It actually uses potential and kinetic energy. The trick is that you have to throw the ball up and you have to catch it in this cup. But the issue is a lot of people try and do it. They pull the ball up really high and they try to have it land really far, and it always bounces out of the cup and they don't know how it works. We want to catch it when it has a bunch of potential energy, not kinetic. So when you pull something up, it's actually going to stop at a certain point and come back down. All you do is pull the ball up, put it right underneath it, and then it will stop, just like this. Oh, I messed up. Let me try again. There we go. And it lands gently. If I pull it up and let it fall down really fast, it's not going to land incorrectly. I want to make sure to land it at the top of its jump. And this is a really fun game if you've never played it. There's more simple versions where you just land the ball in the cup, and it's the same idea. So the two big words we learned today were potential energy, energy that's from gravity or from building up tension, and elastic energy. Not elastic, sorry. Kinetic energy, energy that has motion. And you notice my super awesome pendulum? If you want to make one at home to figure out how this works, all you need is a piece of string, and you can just use any two Legos, but you need something with weight. I just like to take apart the two Legos and pinch the string in the middle, and then put them back together. Now I have my own pendulum that I can use. So I can test it, hold it up to one side, and see that it swings. This is actually going to work a lot better because the string is lighter, so it's going to keep more of its energy. You notice it's still going, and it's still going. It's still going. The potential is changing to kinetic over and over again. That's all I have for you guys today. Thank you for tuning in with Real Inspired Learning. My name is Mr. Dayton, and don't forget to check out New Minds TV. Don't forget, you guys are really awesome and you all love different things. Those are your passions. Keep following your passions until they become your talents. I hope you guys have a wonderful day.